This is a test for a single proportion. Here's the problem. A widely held belief among expectant fathers is that babies are not born uniformly throughout the day. They choose to arrive instead at times purposely inconvenient. To test the notion statistically, a maternity hospital reviewed the records of 2,650 births. Out of that number, some 494 were born at a conspicuously bad time between midnight and 4 in the morning. Let the null hypothesis be that the births occur at purely random times throughout the day. Under this assumption, what proportion of babies would be born between midnight and 4 o'clock in the morning? Well, the answer to that is what share of the day is the first 4 hours of the day? Well, it's 1/6 of the day. So, in fact, what we would expect if the arrivals were uniformly distributed, that about 1/6 of the babies would be born between midnight and 4 a.m. That's our null hypothesis. P is equal to 0.167. The alternate hypothesis, of course, is the opposite. P is not equal to 0.167. Okay? Test statistic. All right. Test statistic is a Z. The formula looks like this. P hat minus P divided by square root of P times 1 minus P divided by N. We write 1 minus P in my class. Some formulas show Q there. What's P hat? P hat is the sample proportion. The sample proportion is what percent of 260, or 2,560 rather, it's 2,650, is 494. Well, we use a calculator to find that out. Here's 490, whoops, I can turn it on, I suppose. 494 divided by 2,650. And the answer is 0.1864 or 0.186. Let me just write down here 0.186, and just for memo purposes, P hat is 0.186. I'll just put it up there so you've got it to refer to. Minus 0.167 divided by square root 0.167, that's the hypothesis, times its one's complement, which is 0.833, divided by 2,650. The calculation is as follows. It's 0.186 parenthesis 0.186 minus 0.167 unparenthesis divide parenthesis second square root 0.167 times 0.833 divided by 2,650 on parenthesis. I'm putting an extra parenthesis for luck. And the answer is 2.62. Z is equal to 2.62. Okay? We'll write that here. 2.62. The critical values, we have got what? We've got alpha equal 0.05, two tails. So we got plus or minus 1.96. And that shows us our rejection region is here, and so we reject H naught. Okay. How do we say that in plain English? Well, for that we go to our little helper here, and what our little helper says is that we start off by noting that the claim, I should have written that, this is the claim is H naught, and we rejected it. Therefore, there is enough evidence to reject the claim. There is enough evidence to reject the claim that, what? Well, the claim is essentially that babies are born uniformly throughout the day. That was the claim. Are born uniformly throughout the day. Okay. P-value. Well, p-value is associated with our test statistic, which is 2.62, and we look for 2.62 here, and here is 0.02. Here's 262,99560. I'm not going to do the arithmetic, especially since I know I have to double it for the two-tailed test. So what I'm going to do is I'm going to use the other end of the table. Here's minus 262, get 0.0440. Of course, since we have a two-sample test, or a two-tailed test rather, we have to double that. So our p-value is going to be 0.00880. Right now, 0.00880. Okay, let's use the calculator to do the same problem. Okay. Stat tests. This is a one prop Z test. That's number 5. Okay, and it looks like the data are already in there. There's the null hypothesis 167. Notice here that the calculator wants to calculate p hat on its own. So we have to tell it that in the period of interest there were 494 babies out of 2,650. We also notice that we've got a two-tailed test, and so all we have to do is go down here to calculate, and when we do, we get z is equal to 2.68. Well, that's not the same thing as 2.62. It's close. Fact of the matter is, when you're doing statistical work, the right answer basically is, do you reject the null hypothesis or not? I mean, the fact that we're off a couple of cents is not significant. The reason we are is because the calculator carries forward all the decimal places in the sample proportion. So it's going to have a bigger number. So it's going to be, so the z is going to be bigger, and the p-value is going to be a little bit smaller. And so it is. We got 0.0088. He got 0.007, but we got the right answer. The calculator results do not contradict the results of doing it by hand. And you should expect to see this anytime you have got, you're doing the problem two different ways. It happens with proportions. So that's how you do one proportion z-test.